Hello friends, welcome to the today's session and welcome to Unacademy. In this session, we are going to discuss about process synchronization. In the process synchronization, our today's task is concurrency and race conditions. So what is a concurrency and what is a race condition and what is the problem if you are having race conditions and why race conditions are not suitable for your multiple processor architectures. We will look
And
at
why
into
race conditions are not.
we will look at into in today's session. So before going into details, first let us understand our anthem. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get plus subscription and access unlimited live and recorded courses from India's best educators. About myself, Srinivasarao Sir, having 17 years of GATE experience in the subjects of operating system, database management, and computer networks, and also have relevant certifications in the respective fields. So, throughout my journey of GATE, I taught in many premium GATE academies, including the GATE Forum, GATE Academy, and MadeEasy too. So, this is detailing about subscription. There are two kinds of subscriptions, 12 months and 24 months as far as GATE and ESE concerned. So if you are currently running a fourth year student, you opt for 12-month subscription. Third and second year students can opt for 24-month subscription. So please feel serious that the importance of the subscription. Here when we take the subscription in an academy, you're going to get all kinds of privileges to access all kinds of lectures of other faculty members too. So therefore, take the subscription and enjoy the complete pack of unrestricted access of your curriculum. This is about 24-month subscription. You may use my referral code before taking the admission to get the 10% off. So use my referral code Sankara to get the 10% off and enjoy the sessions. So this is schedule about upcoming classes of operating system in the month of August. So as far as today's concern, we are learning about serial execution, concurrent execution, and race conditions. Let's crack GATE CSE. That's our YouTube channel of CSE. And subscribe to Unacademy YouTube channel. Use my referral code. Hit the bell icon for latest notifications and updates. Now let us go into details about process synchronization. This is a very vast and very important in real-time scenario, especially how the operating systems are being built. You will understand once you know the concept of inter-process communication, also called as process synchronization. So there are IPC and inter-process communication and your process synchronization are almost all similar. But why IPC we are going to use in process synchronization, we will learn in the upcoming lectures. As far as today's session, as we are learning as a part 1, in this session we are going to learn about what the types of executions are there and what the each execution is going to pros and its cons we are going to look at. And after that we are going to see what is a critical section and what are the important properties to satisfy your critical section we will learn in this session. So as far as process synchronization concern, I want to put it the content like this. So first we understand what the types of executions we have. We know there are two famous executions. One is your process can be executed serially, and the other one process can be executed concurrently. So, what is the advantage and what is the disadvantage of the first methodology of execution, that is serial execution? When you are talking about serial execution, we know that the processes are executed one after another. This is the point. So when you are saying that the processes are executed one after another, then you say that if there are two processes or two threads, whatever you talk, I don't mind. It may be a thread or it may be a process. Both are similar only because thread is a part of your process. Now, when I am running some kind of statement 1 here and a statement 2 here, so after completion of your statement 1 and statement 2 of your process 1, we will begin other particular process statements like statement 3 and statement 4. So what is the advantage with this? Is a fantastic advantage. What is that? You never have any kind of a problems or conflicts among your P1 and P2. That is the advantage. Because after completion of P1, the P2 is going to start. Therefore, whatever the buffered values are there, they are going to be reached to consistent state. Please recollect a database management system concept. So what happened? Your P2 is going to run only after completion of your P1. Otherwise, one more also we can able to define that the P1 is going to be followed your P2. This is also one more way to execute it. So what is the advantage here? You see that advantage with serial execution, if you understand, please look at. So what is the advantage here? Accessing resources uniformly. This is the first point. The processes are executed one after another. We are not going to stamp each other. Stamping is nothing but overlapping. We are not going to do any kind of overlapping during the execution. And even you provide the concurrent threads, the operating system IPC is a very tough one to beat it. Why? Because even you provide a concurrent mechanism threads, it is going to put it in the form of serial execution according to your multiprocessor structure. If I am having a single processor system, then if you are giving n concurrent threads, it is going to take only one thread at a time. That's the beauty of your inter-process communication, also called as a process synchronization. If you are having, for example, 8 process octa-core, if I am having, so if you are sending a concurrent threads, n threads, then it is going to execute maximum 8 threads or 8 processes as you are having octa-core system. So who is going to do all these things? This all is going to be done by your one of the component called operating system resource manager, resource allocator. Along with that, we have the concept called inter-process communication. So operating system, it is inbuilt mechanism IPC. It is going to provide a proper process synchronization such that you never have any kind of overstamping or conflicts or overlappings. So what is the advantage here? As you are following one after another, you are maintaining a proper queue. Whenever you have a proper queue, then one by one requests are going to be satisfied. Therefore, there will not be any problem with the supplier as well as the customer. For example, you are standing in front of a booking ticket queue. So there is only one person who is going to sell the tickets. So he is going to handle 1:1 concept only. So one after another, next guy is going on, then after that next guy is going on, after that next guy is going to take the ticket. Therefore, there will not be any kind of a problem in this. So that's why you see that everybody is going to get a uniform or unique ticket numbers instead of getting same ticket numbers. That's what IRCTC and real-time ticket booking and real-time token management system, these are all being done using inter-process communication only. The token numbers are never been overlapped to each other. For example, if you go to restaurant, then they are going to provide a token numbers. So as and when your token number is called for, then only you are eligible to occupy the seats. So who is going to do that? Complete system is inbuilt mechanism which is available in your operating system. So what are the problems with your serial execution? So we know that the starvation, obviously, because nth request you want to satisfy means n minus 1 to complete, before that n minus 2 complete, before that n minus 3 complete, and so on. It goes to the first one. First one has to complete. Therefore, what is going to happen if you are having n processes, then you need to see that it is supposed to satisfy all your request, then only you are going to get nth process request. There may be a chance of what? Starvation. Now let us see concurrent execution. What is the concurrent execution? Please let me show you one figure here. So here what is going to happen? There is a process 1 and there is a process 2. They are having some kind of a statements here. Statement 1 is with P1 and statement 2 with P2, statement 3 with the P1 and statement 4 with the P2. If I say that concurrent access is being done, concurrent access is nothing but, please understand that, interleaving. When I am saying that interleaving allowed, interleaving is nothing but the threads can execute concurrently. That's meaning of interleaving only. Therefore, what happened? Sometime S1 first it will execute, then it will execute S2, then will it execute S3, then it will execute S4. This is a one model of execution. So you know that which thread is going to access in a proper way. This is a first P1 will execute, then P2 is a preempt your P1, then again P1 preempt P2, then again P2 comes to get the chance. There are many kinds of ways. If I am taking other way that, so S2 initially started, then S1 will be executed, then S3 is going to be executed, then S4 is going to be executed. This is another one, and the other one is nothing but S1 is started initially, then S3 is done, then after that S2 is being executed, then after that S4 is being executed. There are n factorial ways. You know how to write. We already learned. We learned that you can write up to n factorial formation. So this is what is the meaning of concurrent execution. So what the concurrent execution is nothing but your threads are going to be run each other concurrently, and there may be a chance of preemptions. This is very important. Whenever you talk about the interleaving, there are some preemptions are there. That means a thread or a process can able to preempt others and occupy the resource. So because of this kind of a preemption, what is going to happen? Your resource is going to be shared among the processes. Whenever you say that resource is going to be shared among the processes, and the processes or threads can able to execute concurrently to access that resource, is a concept of concurrent execution. What is the advantage? Superb advantage. P1 is not waiting for P2 and P2 is not going to wait for P1. At least they are going to get a chance to execute them. Therefore, you say that concurrency is very high. So whenever you see that concurrency is there, there is no concept of a starvation in this case. So that is the advantage. What is that? Concurrency is very high, and you say that starvation can be almost all minimized. So what is the meaning of concurrent execution? You say that interprocess, uniprocess system is allowing you interleaving concept. Interleaving is nothing but accessing the same resource by multiple processes concurrently. But what is the problem? A big problem here. If I am using a concept of processing, if I am using a concept of concurrent execution without having a process synchronization, obviously you are going to get overlapping to each other. So whenever you see that overlapping to each other, which is going to give you incorrect results. So this incorrect results is going to provide a concept of what? Inconsistency to your database. That kind of inconsistency we are calling it as a what? A race condition. So what is a race condition? So race is nothing but there are two or multiple number of processors fighting to access the resource, and obviously they are going to get overlapping or overstamping, which leads to inconsistency, or you can also say that conflicts. So that's what. So what is the drawback? Inconsistency because of what? Conflicts. Obviously read write and WR and WW, which are also applicable in this. Whenever you talk about the sharing of resources is available, then you are also automatically talk about RWW or NWW conflicts here too. And that too, it is going to provide a concept what? Incorrect results. Whenever you see incorrect results, the incorrect results only you will see only what? Concurrent execution only. That providing of incorrect results is mainly the cause. That is what? A race condition. So now, after understanding what is a serial execution and what is your concurrent execution, now we will see that the main problem with your concurrent execution is race condition only. So what is a race condition? Let us see now. So when you talk about the race condition, there are multiple number of processes. You know football game. You all know football game. You will understand what is a race condition. You will understand. So football game is nothing but there are 20 players are fighting for each other to acquire a ball. Please understand this ball is your common. It is a common resource to all the players. Common resource to all the players. Therefore, what will happen? Only one resource, but that is going to be shared by multiple number of parties. Therefore, what happened? We don't know that the ball is at which position right now. At some instance, the changing of the ball is going to be vary. Sometime the ball with the player 1, sometime the ball with the player 2, sometime the ball with the player 3, and sometime the ball with player 4. All of their goal is only one. What is their goal? They have to take the ball from each others and see that their ultimate aim is nothing but we want to send it to consistent state. That is nothing but they want to hit the goal, or you want to say that execution we want. So whenever you see that execution you want, in the sense there is only one resource is available, that is accessed by multiple number of processes or players, and ultimately who is going to hit the goal, we all know. We don't know. Either P1 may hit the goal, or 2 may hit the goal, or 3 may hit the goal, or 4 may hit the goal. But we know that who is going to hit the goal. Who is going to hit the goal? The guy who hold the ball at the last instance. So reminding there are many passes are there among the players, but the last pass whoever got, he is only the person who can able to hit the goal. That means the output is ultimately depends upon the last executed process or the last executed player only. So remaining players are what? They are in the buffer only. They are not going to be considered. They are only for what? Exchanging of the ball, but ultimately the last goal hit by the only one person, he is the person who performed at last. So because of this, there is a concept of what race condition, because race condition is nothing but creating a confusing, creating ambiguity while accessing the resources is a concept of a race. That's why it is put as a condition called race, like a running race only. For the running race, many number of persons who are running to achieve the first. So therefore, here also we don't know that who is going to achieve during the race. So the guy whoever hit the last, the final thread, he is going to win the race. Here also, what is the meaning of that? It is a situation where two or more processes are competing together to access a shared resource. To access a shared resource. So whenever you have a shared resource, then there may be a chance of a race. Whenever you say that concurrent execution is eligible, then there is a race. So when there is a race among the processes to acquire the shared resource, then your final output is depends upon only the guy who is going to execute it at last. The final output of any variable on the execution sequence of the processes only. So in that case, if I am saying process 1 first executed, process 2 next executed, process 3 next executed, process 1 last executed. Now you see your final output is only in the hands of P1. Please understand. Your final output is only in the hands of P1. It's not in the hands of P2 or P3, because whoever performed at the last, whoever is performed at the last, he is a main person. He is responsible to generate the output. So this kind of a condition is called race. Naturally, we see these kind of race conditions in real time also. So now, when the race condition is going to happen? Race condition is going to happen in few cases. One is a resource must be shared. This is very, very important. If resource is not shared, then there is no concept of a concurrent execution. Again, I am telling you friends, please observe this difference. When I am saying shareable resources and non-shareable resources, yeah, so serial execution, no conflicts because the process one completely executed and leads the output, then the process two is going to begin. That's why we cannot say that serial execution, nothing have, they are not going to be affecting or affected by others. Yourself is committed. That's the meaning. So one is a shareable resource, the other one is a non-shareable resource. So when you are talking a shareable resource, I can say that you can able to execute them concurrently. So concurrent access is allowed only for what? Shareable resources only. So when you take that non-shareable resource, then there is no concept of concurrency here because concurrency is nothing but what? Multiple numbers must acquire, multiple process or threads must acquire global variables. So when I am talking about the global variables, please understand when I am talking about the global variables or global data, they comes under into shareable. Therefore, it is going to be shared to all the processes who are live or who are active at that particular time. In non-shareable resources, I can name it as what local data or local variables. Whenever you say that local variable, they are under non-shared, which cannot be accessed by others. It can be accessed only by the particular process only, and so there is no concurrency here. So when there is no concurrency here, there is no concept of a race here. When there is a no race here, there is no concept of what? Inconsistency. So no inconsistency here because the resource is not shared. When the resource is not shared, then there is no concept of a race here. So but here it is not like that. So the things are globally available, anybody can able to access at a particular instance of time. Therefore multiple processes or threads or users are trying to access it. This kind of accessing is called as a what? Race. So whenever you talk the race, then there is a what? Inconsistency. Please understand friends, this is the difference between shareable resources and non-shareable resources. As per as the previous one, a race condition is only for shareable resources, not for non-shareable resources. In shareable resources, multiple processes or threads can perform read and write on the data items at the same time. That's very, very important. At the same time, they are going to do. There may be a chance of overlapping or overstamping. This overstamping is being done, is being what I mean to say overcome by inter-process communication or process synchronization. So now you observe carefully. They do so in a way that the final output is only depends upon the order they execute the process. Who is the main responsible for the final output? The guy who finishes the race at last. Please understand. The final output depends on who finishes the race at last. He is the ultimate responsibility to provide your output. So that's what the meaning of what race condition. So remaining values, they are going to be in the buffer only, but at last whoever executed the last, then he is the main responsible to finish it off execution. So now let us see what are the problems with race condition. The problems with race condition is we already learned conflicts. The conflicts will give you inconsistency, then there may be a loss of data. So like ww, both are overwriting each other, that's the meaning of loss of data. There may be a chance of what? Deadlock. So what is a deadlock? Let us see the three different examples on three different conditions. When you are talking inconsistency, please understand this is the first problem which I want to highlight, why the race condition is going to generate inconsistency among the processes. I say there is a thread 1 and there is a thread 2. In exam he will be asking like this only. So he will mention threads are a process, you need to understand how they are going to be executed. I say that Both are accessing. There is a variable called A. The initial value of a variable A is 100. Now you see, he is writing addition and this guy is writing subtraction. Then what is going to happen here? So if I am executing concurrently, then what is going to happen? First step, P1 executed. Please understand, friends, why I am telling you. These are all the simple examples so that you can easily understand the tough concept. Observe the way I am executing. Let P1 begins, and P1 begins, and he said that A is equal to 100 I started. Then I am issuing incremental operation. A is equal to A plus 100. Then I am writing its value W of A. So now it becomes 200. So when I am saying that it is not yet done because you say that concurrent access is there. Now A is a common resource to P1 as well as to P2. Here A is a shared resource. Now P2 got executed immediately. That means P1 is preempted in this case. Please understand. Please understand, whenever somebody is taking from you, which is nothing but what? P2 preempts. So when P2 preempts, interleavings are allowed. Please understand. In shareable resources, interleavings are allowed. Interleaving is nothing but concurrent execution only. So P2 preempts P1. Now you say, so P2 executed this time. So when P2 executed, then he sees that A is equal to some number. So again he will read the A value. If he able to read the A value from starting, he will get 100. If he read the A value from the buffer, this is the value he will read. I say that A is equal to 200. I am doing a decremental operation, that is A is nothing but A minus 100. Again if I am saying that W of A, then it goes back to finally the starting value. So there is inconsistency to P1 because I performed a right operation, somebody is performed reverse to that. Therefore, you see that there is an inconsistency. There is an inconsistency to the first process, that is a P1, because there is a race between P1 and P2 here. P1 is also working with a resource A and P2 is also working with resource A, and they are fighting for a resource A, and finally the output is ultimately depends upon the last guy who performed the action. So now the guy who performed the action in this is a P2, which the value is not 100% consistent because that was the value I read from your recently from P1 only. This is inconsistency. And what is the second one? A loss of data. So here the example also can fit here. What is the loss of data here? When I am saying that, please understand what is the loss of data. There are two threads or two processes are here and both are sharing A is equal to 100 like this. So initially if I am performing as per as a previous example like this, W of A, other self is doing a decremental and W of A. Now what happened? First let us execute this time. Let P1 executed. Please understand, friends. When P1 got executed, he sees that so 100 and he is making a plus 100 here, then A becomes to 200. As it is a shared variable, the other guy also could able to see that. He said that let P2 executed. When I am saying that P2 executed, P1 is preempted here. So he make reverse operation. So 200 minus 100, that is equal to A is equal to 100 in this case. Now again, this time let see the equation I am executing. Let P1 executed. Then after executing, he is saying that he wants to do abortion. So when you make abortion, then what will happen? Your A value is going to starting. Therefore, here who is going to lose his data? So the P2 data is going to be lost in this case. So you can take any kind of example like this. So whenever you say that overlapping, then there may be a chance of loss of data and inconsistency. Third one is so dangerous. That's what it also sometimes leads to deadlock. How deadlocks come? So deadlocks obviously will come whenever you talk about the concurrent execution. Whenever you say that concurrent execution without having a proper inter-process communication or without having a process synchronization, there is a chance of a deadlock. We know there is a process 0, operating system always suffers from deadlocks only. Process 1, So here object A is with P1 and object B is with P2, and here I am putting a request here and generating a request here. Why he is keeping a request on to A and why he is keeping a request on to B? Here I need to tell you that very important point. A and B are what you can say shared resource. Whenever I say that A, B are under shared resource, each other can able to request to each other, and finally they are going to enter into what? Deadlock. So when we are asking a concurrent access, it's only for shareable resource. When you are asking shareable resource, then maybe chance of race condition. Race condition leads to three important problems, that is inconsistency, loss of data, and deadlock. So any doubt you can just post, as this is a live session. I hope so you got clear what is the problem with race condition. Race condition is nothing but multiple processes or multiple threads are fighting to access a common resource, and during this access they are going to fight each other to acquire a common resource. So during this acquire a common resource, there may be a chance of each other may kill, each other may preempt. Therefore what is going to happen? One thread may be live, one thread may be alive, because they are going to fight happening to access the common resource. This kind of a fight is the concept of what? The race condition. So who is going to win the race? Whoever preempt almost all other processes and myself is alive finally, then I am going to be the final winner. So whoever winner is going to be ultimately decide the output of the program. So that's the concept of race. Now you see the very important point. I'm showing some examples here. Now you can tell me how many are serially executed, how many are concurrently executed using a two threads like thread A and thread B. So there are two threads which are there, and thread A consists of three actions and thread B consists of two actions. So identify the valid sequence of statements. I can tell you friends, you know the DBMS concept that you can have how many total runnable statements are 3 plus 2 factorial. Please don't forget this equation that is applicable here also, and 3 factorial into 2 factorial. These many varieties of combinations you are going to get to execute this. I have provided some of the sequences. Now you tell me, are they valid or invalid? The first one I am talking. So A1 is executed. So when I am talking A1 is executed, please understand carefully. First thread is come into the picture, that is thread A is executed here. Then after that X1 is executed. So what is X1? X1 is done by thread B. Then after that Y1 is executed, that is also done by thread B. Then after that B1 is executed, then that is done by thread A. Then after that C1 is executed, that is done by thread A. So the first one is a perfect execution, which is a concurrently executing sometime A, sometime B, sometime A. Now come to the second equation. The first thread A is going to execute here, and second thread is also executed by A, and third thread is also executed by A, and next action is done by B, and next action is done by B. This is a perfect, it's a serial execution. Please understand, it's a perfect serial execution. Next one, A1 is executed by thread A, and this is a thread A, and this is a thread B, and this is a thread B, and this is a thread A. This is also perfect execution which belongs to concurrent. Now you see the next one, A1 is done by thread A, and X1 is done by thread B, and B1 is done by thread A, and Y1 is done by thread B, and C1 is done by thread A. There are swappings each other. So that kind of a swapping we are calling as what? Concurrent execution. That means preemptions are happening there. Now you say, so thread X1 is executed by this, and now this is executed by B, this is executed, A1 is executed by this. Now see. So X1 is belongs to thread B, Y1 is belongs to thread B, and A1, B1, C1, they are all purely belongs to A. It is a serial execution because first B is executed, followed by A is executed, In this, A is executed followed by B is executed. Now this is a concurrent, this is a serial. Now come to the next. So this is A1 is executed, that means thread A, and Y1 means a thread B, X1 means a thread B, and B1 means your thread A, and C1 means your thread A. So you may feel that there are multiple, so sometime A is executing, sometime B is executing, but we will say that this is invalid. Why this is invalid? Because internal swappings must not be done. However, the statements are given in the same way you are going to execute the lines. So first this is executed, then this one is to be executed, then this one is to be executed. But why this is invalid? Because of this. There is within the process you are trying to do interswapping. That interswapping within the process must not happen. You can change the sequence of execution, but internal swapping must not be allowed. Now here x1 is done by B and y1 is done by B, but b1 a1, please understand this is also not possible because the first action which is to be done in the thread A is a1, it's not b1, therefore it is invalid. This is how you see that how the serial execution and concurrent execution is to be done. Now let us see the next one. So this is a one example. There are some serial executions and concurrent executions are mentioned. Whenever I am saying that concurrent execution, there are some chances of race conditions. Race conditions will give you inconsistency or loss of data, or at some time it leads to deadlocks also. Now here what happened? Initial A value is a 5 and B value is equal to 3. Now you observe, find the sequence so that A value can be a maximum. I want to see that maximum value of your A. So which of the sequence is going to generate that? First let me execute the first one. So what is the first one? I say I will execute S1 first, then I will execute S3 next, then I will execute S4 next. As far as given option I am checking, then S2 next. So here what is going to happen, friends? Observe. So S1 is nothing but A is equal to A plus B. A is equal to A plus B. So we got finally A value is nothing but 8 in this case. Now after that S3 come into the picture. So S3 is nothing but the thread 2 or a function 2 is executing here. So S3 is nothing but B is equal to A star B. So B is equal to A star B. So already the latest A value you need to consider here. The latest A value is 8. That's the meaning of preemption. The latest A value is 8 here. So therefore 8 into your B value. Your B value is fixed there. So therefore the B values goes to 24 here. Then statement 4 is executed. A is equal to A minus B. So your A value is 8 and minus 24. Your B value, recent B value is 24. Therefore it is minus 16. Now if you execute S2 now, what is your S2? B is equal to B minus A. So B value is, latest B value is 24 and minus your A value is a minus 16. Therefore it is almost all 40 in this case. So next one, if you execute the second option, so what is the second option? Observe carefully. So S1 I will execute, then S3 I will execute, then S2 I will execute, then S4 I will execute. So using this sequence, what will happen? This is also concurrent execution. This is a concurrent execution, no doubt. This is also concurrent execution, no doubt, because swapping among the functions or threads are being preempted each other for some times. So as usually, this is A is equal to A plus B, that is nothing but 8. S3 come into the picture. So B is equal to A star B, that is nothing but 24 we written. And S2 is implemented. What is S2? B is equal to B minus A. Please observe, friends. So what is B is equal to B minus A? So here the B value is a 24 here and A value is the very latest one, 8 here. So the B is equal to 16 in this case. So we want to see the statement number 4. The statement number 4 is A is equal to A minus B. So what is your A value? very latest A value is 8 here. So 8 minus your B value is a 16. So your finally your A value is going to be minus 8 in this case. So this is, see that why I'm telling you this example. This example you need to understand clearly. If I execute in a first way, that means if I conduct a race as like the first, please understand. If I am conducting a race as like first, your output is a what? 40. Who is the responsible? Statement 2. That is a function 1 is responsible to generate this. If I am execute, if I conduct a race like this, then what is going to happen? The final output is a minus 8. Who is responsible to do that? The last guy, S4. If I execute like 3, so what is 3? S3 first, S1 2, and then S2, then S4. You are going to get one value. If I execute less, if I execute like this, you are going to get a one value. If I execute like this, you are going to get a one value. If I execute like this, you are going to get a one value. Is I understanding that which sequence is going to give you the maximum, you need to compare like this. So finally, this example is broadly telling you that the final outcome is ultimately in the hands of the last statement or the last executed process or last executed thread. That's why you are seeing a different values. So one time you have got 40, one time you have got this value. If I execute, for example, let us execute sixth case. If I execute sixth case, what will happen? First I am executing S3. What is S3? B is equal to A star B. So A star B is nothing but it is going to give you 15. S3 itself is going to give you 15 first of all. Then after that I am executing S4. Your S4 is nothing but what? A is equal to A minus B. So this is S3 is nothing but what? B value. Now when I am saying A is equal to A minus B, your A value is a 5 and your minus your B value is latest 15, then you are going to get a minus 10 here. Then after that you are going to execute S1. After executing S1, your S1 is A is equal to A plus B. So therefore what happened? Again you got the latest value, that is a minus 10, and your plus B, the B value is nothing but in this case 15. Therefore you are going to get a 5 here. After that I am going to execute S2. What is your S2? B is equal to B minus A. You are going to get different value this time. So when you are talking about a concurrent execution, every execution you provide, it is going to give you a different value. The providing of a different value is the concept of a race condition, obviously. So to avoid this race condition, what is required? There is a requirement of what? Process synchronization, also called as inter-process communication. So in order to avoid this problem such that whatever way you execute, I don't mind, all threads must give you the same output. That's the meaning of process synchronization. You execute as like a sequence 1 or sequence 2. There are 6 sequences are given this. Any sequence you come, I don't mind, but ultimately the output is supposed to be same for all the kinds of sequence of execution. That guarantee can be given by your process synchronization or inter-process communication. Now let us see what's the next one. So why there is a need of the process synchronization? So process synchronization is going to avoid all the three problems that you will not find inconsistency, you will not find what? Deadlock, you will not find a loss of data. All the three problems can be avoided just by using a what? Process synchronization mechanism. So process synchronization is not implemented in all the cases. Please listen carefully. Process synchronization is only for limited conditions only. What are the limited conditions? Only for shared resources, only when there are race conditions, only when there are preemptions. You know, all three are belongs to, please understand, all three are belongs to which kind of execution? You can comment. All three: shared resources, race conditions, resource preemptions are in which kind of execution? Which kind of execution? You say that interleaving. That interleaving, we are calling it as a what? Concurrent execution. So whenever you see that concurrent execution or interleaving execution, then you see that there is a what? There is a mandatory requirement of what? Process synchronization. That's why process synchronization only in the following three cases: when there is a shared resources are there in your system, or when there are race conditions are there, or when there are preemptions are there. All are mutually similar to each other, all are speaking to same sentences only, but I am putting in a different kinds of forms. So they all belongs to what? Concurrent execution. So what is a process synchronization? Let us see. I already told you process synchronization is nothing but it's not for serial execution. Again and again I am telling you, when you are having a non-shareable resources and when you are executing a line by line execution of the threads or process, there is no requirement of process synchronization. Process synchronization only when there are limited, that is limited resources, that too they are under shareable resources, then there may be a chance of race. Whenever there is a race, there is inconsistency, loss of data, deadlock. To handle those three problems, there is a, what I mean to say that bring all the concurrent thread execution, put them into serial is the concept of what? Process synchronization. Again, I am telling you. So, what is a process synchronization? Simple definition. You need not worry such a long. So, process synchronization is nothing but what? Okay, you execute concurrently. I don't mind. So, see that because when I'm saying that I need concurrent execution only, when you are allowing a concurrent execution such that they're all trying to access your shared resource. So when you are executing a shared resource like this, then there may be a chance of race condition which is going to give you inconsistency, loss of data and deadlock. But when you apply, I am streamlining now, when you apply process synchronization, and what is going to happen? Your concurrent execution becomes a simple what? Serial execution. So this is what is the concept we already seen in database management system. Here also we are going to present in the same way. Whatever that, get all the requests concurrently. I don't mind. So I do not want to put the processor threads in the starvation mode. I want to allow them to execute concurrently. Let them preempt each other. But you see that I am going to apply a process synchronization. See that serial execution because the concurrent execution will give you inconsistency we learned and you are trying to convert into serial execution because of what? Consistency. So from inconsistency mode we are trying to put into consistent mode. That is the duty of your process synchronization, right? So let us see what is the process synchronization. So the process synchronization, yeah, process synchronization is telling you that accessing your common resources in a proper form, not to keep your hand bring the items from the common resource. So there is a common resource. We are fighting for common resource only. Again, I am telling you, process synchronization is only for common resource or shared resource. When the resource is not shared, there is no concept of process synchronization. There must be a common resource and there must be a multiple number of process or threads who are trying to access and try to put your hands in the box and pull the things that we are not going to provide. What the process synchronization is telling you, even you try to put your hands, it is not allow you to try to put your hands together. It allow you to finally, the process synchronization is mainly telling you to like this. Please understand. When you are asking, many threads are coming. Please understand. Many threads are coming to access your common resource. So there is a mandatory requirement of a common resource to implement a process synchronization. Again, please see, there is a common resource available to me and there are multiple threads are coming like this. But we will not allow you to access the common resource concurrently. Finally, what it is going to tell you, for example, there is a P1 and P2 and P3 who are trying to access concurrently to access the common resource. But what the process synchronization will tell you, the process synchronization will tell you that either P1 or P2 or P3 only can access, please understand, only can access your common resource one at a time. That's the point. Your common resource one at a time. So therefore what is going to happen? Either P1 can access common resource first or P2 can access or P3 can access, but not more than one is not possible to access the common resource. Therefore what happened? your concurrent execution automatically stopped and tried to put it in the form of what? Serial execution only. This is what is the meaning. Accessing the common resource in a non-concurrent way is done by process synchronization. That means as soon as one process is entered to access the concurrent resource, it is locked. Please understand. Whenever one particular thread or a process enters into your common resource, then door is locked. So when door will open, after completion of that process, door will open, resources are released there only. Again, the next process will enter. As soon as the next process is entered to access the common resource, again door is locked. So therefore, other guy has to wait till you come out, exit. So entry and exit is the concept of process synchronization. Okay, it's indirectly you are trying to come in a concurrent way. The process synchronization is not allow you to access concurrent way. It try to put in serial format. Whenever one guy is entered, other guys must wait in order to access your shared resource, not in other cases. So what is a process synchronization? Observe. Sharing a system resources by processes concurrently. Yes, concurrently we are accessing, but so minimize the chance of inconsistency data or conflicts. This is the main concept of your process synchronization, which means that we want to see that there will not be any inconsistency in the data. Ultimately, we want to see that safe and secure, consistent data we want to see. So, as far as process synchronization concern, we are having two types of processes. One is a concurrent, the other one serial. So the concurrent is talking now exact technical term I am talking. This is a concurrent, which is nothing but what? Cooperative processes. This is the serial, which is nothing but what? Independent processes. Observe friends. Now I am attaching those 2 points, the way they are executing to your process synchronization way. What is that? There are two types of processes are available. Cooperative, they are under shared mode. The other one is independent processes, they are under non-shared mode. So which is called as a serial, one is called as a what? Concurrent. So what is the cooperative processes? They are bidirectionally preempt each other to access your common resource. Therefore, if one is modifying, the other one is going to affect, the other one also can able to affect you. So what is the cooperative process? See the figure now. Cooperative process is nothing but they affects other process or getting affected by other processes. So I can able to do some kind of effect to others. Other process also can able to do some kind of effect onto me. What is the meaning of that? Please understand P1 and P2. Let us look at now. There is a read of A. I performed the value of A 200. So immediately I am suspending. Please understand. As soon as I am suspending, so P1 is in a suspend mode, P2 access it, and he said that A is equal to some number here and write off A. Therefore, what will happen? This A value is become 200. I said now in concurrent execution, the final output depends upon all the way the last guy who is going to perform the action. This is the race among P1 and P2. First race started by P1 and that is finished by P2. So whoever finished at the last is the final winner. So your value is a 200 is going to be stored in your respective data. Therefore, what happened? The P2 affects P1. That's the meaning. The P2 affects P1. In the reverse way, if I am taking an example like this, P1 and P2, I say that R of A, I am saying A is equal to 100. Please understand carefully. So I am saying A is equal to A plus 100, and let me say that W of A. We know that the P2 is trying to affect P1, but you see that one more time P1 preempts P2, and I said that what? Abort. Bus. When you say abort, first P1 disturbed you, it caused you. P1 disturbed you, and your value is got affected. And what the P1 is doing? P1 is disturbing P1 now because I am doing a what? Abort. Therefore, what? Each other can able to exchange the values or data or statements or some command, some kind of a commands. Therefore, both are being disturbed each other. That's the concept of cooperative. So then you say that they have to be affected or they have to be affected by other processes, then they are calling as what? Cooperative. This is only applicable only for what? Shared resources. In the event of non-shared resources, we are not going to do like this, because two threads are being executed independently or separately, nobody knows about others. So therefore, what is going to happen here? The execution of one process does not affect or affected by other processes. So P1 is executed alone and P2 is executed alone. Nobody knows about that because they are not accessing any kind of shared resources here. I will execute myself, you execute yourself. That's the concept of independent processes. So now you tell me, friends, before going to next, you tell me, when I am telling you inter-process communication or syncing of the processes, I said two important varieties of processes. One is a cooperating processes, the other one independent processes. So this inter-process communication or process synchronization is mainly for what? Cooperating process only. Because when you talk about the cooperative processes, they are mainly responsible in order to access your shared resource, and everybody knows about others, that how many they are executing, how many times I am preempting others or myself is preempting by others. So that's why mainly process synchronization we speak 100% towards to cooperative processes, not independent processes. So CP means cooperative processes. This is independent process. Independent process, when you talk, so simply I can able to do serial manner. But when you are talking cooperative processes, as there are some shared resource, immediately you talk about the concurrent execution only. So that's why there is a mandatory requirement of process synchronization here. But inter-process communication can also be allowed in serial in order to sharing the memory. So whenever you are sharing the memory, then you say that this is applicable to this, but obviously there also we are using a concept called shared memory. When you talk about the shared memory, again you are talking about what? Concurrent execution. So ultimate entire this concurrent execution topic or process synchronization, we speak only with respect to cooperative processes. Yeah, shared resources done in cooperative processes. So how are you going to implement this process synchronization? So process synchronization is implemented. This is very, very important. Process synchronization is implemented through critical section, also called as a critical region, also called as a critical segment. So what is the critical? What is the critical? Critical is nothing but what? Which is going to be damaged by others. Very sensitive. That sensitive, we want to protect it. How are you going to protect your sensitive information? The sensitive information you can able to protect using critical section. So when I am talking about the critical, it is a sensitive data. So sensitive data, if it is under shared form, please understand, sensitive data which is under shared form, then there may be a chance of what? This kind of race conditions or deadlock or inconsistency data. So how you are going to implement your process synchronization? That can be implemented through critical section. So what is the critical section? Now you see, every process has two sections. Please understand. Every process has two sections. One section is non-critical section. Observe carefully. And one section is critical section. When I am talking a non-critical section, in this non-critical section, I am not going to place any kind of shared resource, which consists of only non-shareable resources only. When you are talking a non-shareable resources, then they are going to be placed in non-critical section because it is not going to be shared with others. That's why you say that local variables, local functions, all we are going to keep in non-critical section only. Other is what? Shareable. This is under shareable. When you are talking about the shareable means it may be a piece of code, it may be a data, or it may be a what? Some file, or it may be a memory. Please see that anywhere you can able to make it a fit to this shared resources. Whenever you say that shared resources, that shared resource must be kept in a critical section because that needs to be protected. So why? What the critical section is going to do? The critical section is going to protect, the critical section is going to protect your shareable resources because they are under shared mode among all the processes. But here we don't bother about here. There is no kind of a protection to your non-shareable resources because they are already not under shareable. This is very, very important. That's why please understand, whenever you get the OTP one-time password, they will say that don't share it to others. If you share that one-time password with others, what will happen? Anybody can able to do anything. That's why the one-time password when you are talking, so must not be shared with others. But when you talk about the memory or when you talk about some kind of YouTube links, when I'm saying, so they are going to be under shareable resources only. Anybody can able to access it. So all global variables. So somebody, so one of audience is shared. Your global variables also comes under into shareable resources only. So please understand, every process runs with two kinds of sections. It runs in non-critical mode. One is run on critical mode. Critical mode is trying to protect your sensitive data. The sensitive data is nothing but shareable resources only. If you not protect this, then it will give a big damage to your particular system or to database. So therefore, please understand. So when you talk about the critical section or a critical segment or a critical region, then there are few sections in that. One is a non-critical section, consists of non-shareable or local resources. And now you observe, this is very important. The critical section, this is. When you are talking critical section, this critical section mainly protects your shareable resources. I want to tell you one real-time example here. See, your RAM, random access memory, is under shareable memory only. So when you say that every process is going to get one different address, if the processes are having same address on your RAM, what will happen? You are going to be, all the processes are going to be, what I mean to say, forcibly stopped. Your system also going to be crashed because you see that every process is going to get a dedicated address which is given by your memory. So your memory is a shareable memory. So in that case, the process synchronization plays a very important role in order to separate your RAM addresses to each and every particular processes. You never see that two particular process is going to get the same address. It's not done at all because the shareable resource is under the what? Protection in critical section. Now our task is, what is our task? How a process can enter into critical section. This is our task. How, please understand, how process can enter into critical section. Why to enter into critical section? Again, you may get it out. Why to enter into critical section? Because the shareable resources are kept under critical section only. So you want to access a shareable resources, then there is a requirement to enter into critical section. As and when you enter into critical section, in that you will find some piece of code is there. You execute it and come back. So unless and until you come back as you are inside, others must not enter into critical section. That's why we want to block others. How are you going to block others? You can block others using lock and unlock section. Please understand. So anybody cannot able to enter into critical section at any time. Please see that only one guy is supposed to enter into critical section. How this can be done? How operating system is going to allow only one person to enter into critical section? Why to enter into critical section? Because to access your shared resources. How this is to be done? This is to be done. See that your critical section is being protected with entry and exit. Entry is nothing but acquiring a lock. Exit is nothing but releasing the lock. Bus. So whoever has the key, he can open the box and access the content. Like a locker, please understand. Your bank locker is under shareable. You can access, or other person who are in your family also can able to access if there is a joint account. Therefore, what will happen? You're supposed to take the key. So if you open key, you only can able to access. Others cannot able to access. That's the meaning of what? There is a lock and there is an unlock. Lock to enter into critical section, unlock to release from your critical section. So if you not unlock, that means somebody is there inside, so others must not able to enter into critical section. That's the responsibility by your process synchronization. Therefore, what will happen? Your critical section is also under protection. Please observe, your shareable resource under protected by critical section, and your critical section is also protected by lock and unlock sections. That's called entry section and exit section. So you want to enter into critical section. A critical section is nothing but, don't imagine anything. Critical section is nothing but which consists a piece of shareable code. You want to execute it, first you have to lock it, then unlock it. During lock and unlock period, others must not able to enter to disturb you. As others are not disturbing you, there is no concept of inconsistency, because you open, execute, access and execute, lock it and unlock it. So somebody will come, again he will open, execute and come out. So this is the concept. So now you understand carefully here. So therefore, what do we understand finally? You say that when I am saying a process X here, I say there is a process X. I am saying int A. I am saying int Z. So Z is a shared resource to you. Let Z is a shared resource. So what will happen? Yeah. So as somebody is asking from audience that RAM is under shareable resources only. It's globally available to all the processors. So every process is going to get a different address, not the same address. That is the duty of your your process synchronization. Now you see there is int A, which is under the control of process X. This is your local. That's not going to be accessed by any other process. You say that there is a process Y. I say here is int B. So B cannot be accessed by X and A cannot be accessed by Y, because they are meant for only local. But you observe one important thing. This Z can be accessed here and Z also can be accessed here. This is your global variable, or also called as a shareable resource. Now you tell me. So I want to access this Z. You want to access this Z. Here Z is a shareable memory. So it has to be protected. So how it has to be protected? It is to be protected using a what? Critical section. Now you observe. Now your critical section has got a shareable variable known as a Z. Now if a process X wants to enter into this critical section to access this Z, what is required? Lock on Z. When I am saying lock on Z, now operating system will validate you whether Z is freely available or not. If Z is not freely available, you are going to be underweight. Otherwise, if Z is freely available, your lock is granted. Here it checks operating system validates. Operating system validate Z is freely available or not. Z is free or not. If Z is free, then it is allow you to acquire the lock. As soon as he is in the process, now the Z is occupied by process X. If somebody is trying to access the lock on Z, then immediately it will give you that you are supposed to be under waiting, because already process X already acquired the lock on Z. So now the Z is busy with process X. How long you should be under waiting? I say, for example, finally, so we will say finally unlock statement. Now here we say that unlock. So when I am saying unlock on Z, now this waiting is being removed. So now he can also able to access your Z. I am accessing Z means what? I am accessing critical section indirectly. Please understand. When I am able to access the shareable resources, which means that you are trying to access the critical section. When are you going to access the critical section? You are going to access the critical section only when you get the log. So what do we understand finally? Your critical section is under protected using a lock and unlock statements. And this lock and unlock statement is nothing but what? Entry section. Please understand. This is exit section. That's why in any kind of theaters, movie theaters, entry is a one side, exit is the other side. Please understand, friends. Why entry is a one side, why exit is other side? Please see. So once the morning show is about to be completed. So noon show people is going to enter. Therefore, if both the persons are entering and exiting towards a one gate, then what will happen? There is a big clash among them. Overlapping is going to be done. That's why exit is other side, entry is a one side. So therefore, what is going to happen? Your critical section is going to be protected using entry phase as well as exit phase. So therefore, your critical section is under protected. The critical section protects your shared variable. So here Z is under protected because unless and until you acquire a lock, you cannot able to access this. So condition to achieve your process synchronization. So you want to say that process synchronization I have achieved, then you need to have a mutual exclusion and a progress and bounded waiting. This is a mandatory. So what is a mutual exclusion? When we are talking a mutual exclusion, one-to-one relationship is required. What is the meaning of one-to-one relationship? Shared resource. Shared resources can be accessed only one process at a time. That's it. So instead of having a many to one, we are writing a one to one. Many to one is nothing but many processes can access a concurrent shared one resource. But I am saying one to one is required. Therefore, what is going to happen? You see that this is your shared resource. Observe, friends. This is your shared resource. This shared resource which is under protection of your critical section. So therefore, inside critical section, how many processes can at a time? Only one process at a time. Only one process can be inside the critical section. So whenever you have one process is inside the critical section, it is saying that what? Mutual exclusion is or mutual exclusion is satisfied. Please understand carefully. Mutual exclusion is telling you that only one process can able to access critical section at a time. Only one process must be inside critical section. Must be inside critical section. So now you tell me one example. I say, so Z is a shared resource to us. This is under protection with a critical section. Please understand. So when I am saying critical section, the critical section consists a piece of code or a global data or shareable resources. Now, there are two processes are entered into critical section. P1 is also accessing Z and P2 is also accessing Z. So how it is possible? How the two particular process can be inside the critical section if you are not having a good algorithm to what I mean say to avoid this kind of a situation, you will have this kind of a concept. What is that? I'm not having a proper process synchronization. Therefore, multiple processes are inside the critical section. Then I can say if anybody asks you, is it a mutual exclusiveness? Then we will say that no, because mutual exclusiveness is telling you that only one process or one thread at a time can able to access the critical section. Otherwise, only one process or a thread can be inside the critical section one at a time. Therefore, it is not satisfying such kind of a property because P1 is inside to access Z and P2 inside the access Z. Whenever multiple threads are processed to access your resource concurrently, again there may be a what? Race conditions. Again we are going to back, pavilion back. That's why in this case we are not following a what? Mutual exclusion property. And the second property is a progress. So this is another important property. What is a progression? This is called as a progression, also called as a progress. What is a progress? A process can enter into critical section many number of times. Please understand. A process one can enter into critical section many number of times as and when others are not interested to access critical section. Others are not interested to access critical section. This is what is the meaning of progress. So what is the meaning of that? Please understand carefully. So there is a jet which is protected with the critical section. I am protecting means it is a shareable resource. Don't forget that. It's under shareable and it is a protected. There are few processes are there. P1 and there is a P2 and there is a P3. You observe that let P1 only wish to access critical section. Only wish to access critical section and others are not interested. And others are not interested. Therefore, what is going to happen? So, we want to see that every time the P1 is under critical section to access jet. So, if I able to see that for any number of iterations, it's not only first, second, third, fourth iteration, as long as others are not interested to access your critical section, we want to permit that P1 should be inside to access your jet value any number of times, any number of repetition. So that concept is called as what? Progress. So progress is nothing but a process can access your shared resource any number of times when others are not required or not interested to access your shared resource. So in that case, the P1 can enter any number of times. This is the first attempt he can, and this is the second attempt he can. This is third attempt he can. So he can access any number of times the critical section because others are silent to access your critical section. This is the concept of progress. And the last one is bounded waiting. So bounded waiting. So waiting time of the process must be finite. That's the meaning. If not, it is leads to starvation concept. Please understand. Bounded waiting means waiting time of the process. Waiting time of process to enter into critical section. This is very important. To enter into critical section must be finite. Must be finite. This is so. If I am saying that unbounded waiting, please understand. If I am saying that unbounded waiting, I don't know that when I am going to get a chance to access your critical section. This leads to starvation. Please understand. So you will get no starvation in the first attempt. This is a no starvation. Because I know that when I am going to get the chance, because my waiting time is a what? Finite. So waiting time of the process to enter into critical section must be bounded, also called as a finite. Therefore, there is a no starvation. I know that when I am going to get a chance. But if you are having indefinite time to access your critical section leads to what? Starvation in this case. So therefore, if I am saying, please understand, let three processes are there. Three processes to access critical section. Why to access critical section? You know, this is the point one. Point two, first P1 is accessing critical section. Then after that, P2 will access critical section. I know that P3 knows, please understand. P3 knows that it will get a chance. It will get a chance after completion of P1 and P2. It will get a chance to enter, please understand, to enter into critical section after completion of P1 and P2. After completion of P1 and P2. Therefore, I can say in this case, it is a what? Perfect bounded waiting. So my waiting time is nothing but two processes are ahead only. So I will get a chance. If I am saying, is a very important question, bounded waiting, people will get confused here only. I say that let n number of process, please understand, let n number of process. Now, can we guarantee bounded waiting to access critical section? No, I cannot say no. Therefore, in this case, I will say that this is infinite waiting to the nth process because nth process depends on n minus 1 and this depends on next n minus 2 because the process synchronization is nothing but order of execution one by one to acquire the shared resources. Therefore, I will say that can we guarantee bounded waiting in this? No, it's not possible. So bounded waiting means what? The process which is under waiting to acquire the critical section, it must know that how many are what I mean to say, how many processor or threads are ahead than you. Then you will come to know that 100% you guarantee or satisfy your bounded property. Well, friends, this is the today's concept. What is the today's concept? Types of execution, serial and concurrent. Advantage of serial, disadvantage of concurrent. The disadvantage of concurrent execution is nothing but race condition. Race condition, three problems: inconsistency, loss of data, and deadlock. To avoid the race conditions, there is a requirement of process synchronization. What is a process synchronization? Accept all the threads concurrently to access shared resources, but they let them execute serially one after another because the shared resource is going to be protected by critical section. Critical section is under the protection of entry phase and lock exit phase. Entry is nothing but lock, exit is nothing but unlock. So you want to satisfy process synchronization, three important properties to be satisfied. One property we already learned, that is only one person can allow you to access your critical section. Number two, progress. He can goes on keep on accessing the shared resources when others are not interested. And third one, bounded waiting. The waiting time of the process who are to access into critical section must be finite, must not be infinite. That's it, friends. So tomorrow in the same time 2 o'clock we will continue implementation of critical section using software and hardware solutions. Tomorrow I will discuss two process solutions, that is Peterson algorithm, Decker's algorithm and lock variable, right? And today there is no special class because today special class questions and tomorrow special class questions we will do in the tomorrow session only. So don't forget, don't wait for today's class, otherwise you will be unbounded. Please, again I'm telling you, tomorrow is only your class. We will meet tomorrow, 2 p.m. YouTube class. Please understand. And we will do as usually tomorrow only special class. So I'm telling you, your waiting time is bounded. Your special class is 7 p.m. Please understand. Today there is no special class because today questions and tomorrow questions we will solve in tomorrow special class only. Tomorrow YouTube class we will meet to continue the Peterson algorithm, Decker's algorithm, and what I mean to say Peterson solution 1, solution 2 and lock algorithm we will look at in tomorrow session. So we'll meet in tomorrow exactly by 2 p.m. and evening class tomorrow only, that is 7 p.m. Thank you very much. Stay tuned to Unacademy and get the admission. If you're not yet done, if you've done, thank you. If you're not yet done, please be serious, take the admission, get the complete pack. Thank you.